Okay, section 3.6, solving decimal equations. Tonight we're going to be looking at problems and equations that involve decimals, and we will talk about sort of how we proceed when we are dealing with decimals in a bunch of different contexts. Okay, so it says sometimes equations have exact answers that are not always practical, and it becomes necessary to round. Okay, this can sometimes lead to round off error. You will be required to know how to round, so make sure that from your elementary school days you remember how to round to the tenths place, round to the ones place, round to the hundredths place, round to the thousandths place, etc. And if you need help with that, get with one of your group mates, or maybe come see me during my office hours if you're a little rusty on it. So we'll just look at a very simple problem. It says Manny, Mo, and Jack just finished working on a car and want to split a pizza. The total cost is $12.89, which they will split 3 ways. So you come up with this model of 3x equals $12.89, and that x would represent the amount that it would cost each person if each person is putting in money equally, right? Since there are 3 people, we're saying 3 times the x. Okay. Now to solve that, it would be pretty simple. That's a basic one-step equation. What would you do to both sides? Well, you would just divide by 3, right? And particularly when we're working with decimals, don't feel like you need to do this out on your paper, although it's good to remember. Something like this should be performed in your calculator. So you might want to go ahead and type that in really quickly just to make sure it comes out right. Now, what you're going to get in your calculator should be something that looks like this. And because we have this repeating decimal here, that doesn't really make a lot of sense in terms of physical money, in terms of dollars or physical coins. So we're going to have to do some sort of rounding here. With money, it's a good idea to either round to the nearest whole dollar, but $4 wouldn't really make sense here because there's going to be a little bit left over with change and such. So if we're not rounding to whole dollars, we are usually rounding to the hundredths place, which is the place of the penny. So you would want to round to the hundredths place. Just remember, the 4 is in the ones, that's the 2 is in the tenths, the 9 is in the hundredths, and this first 6 is in the thousandths place. And just to go back over your rules, if you are rounding to the hundredths place, the number you're actually going to look at is going to be the one just to the right of it. So you'd be looking at the 6, and the 6 is going to govern what happens to the 9. And this is where you have the rule, if it's 5 or higher, then the 9 would move up to the next number. So 9 would move up to 10, and that 1 would go to the next place over, and that's where we get this answer. X is approximately equal to $4.30. They're going to have to round up that penny to kind of make it work. Okay, now since we don't have an exact answer, when you round, I don't want to see you guys use an equal sign. You want to use an approximation symbol, and that's kind of like a double tilde, and it's pronounced is approximately equal to. So our answer for x is approximately 4.30, rounded to the nearest cent. So just kind of pay attention. Sometimes they'll tell you, hey, round to the tenths, round to the hundredths, round to the 10,000ths. Sometimes they won't tell you, and you're just going to have to maybe use context to round to the place that makes the most sense. Okay, so that's one topic. Here's the next topic. It says equations with decimals can be rewritten as integer coefficients by multiplying by some power of 10. That seems very wordy, so let's make sure we understand what we're talking about here. Okay, the first term is this integer coefficients. What does that mean? Okay, well, a coefficient, remember, is a number that's in front of a variable. So let's say something like 3.4x. And notice I deliberately put a decimal in there. That 3.4 is what we call a coefficient. Okay, now, is this coefficient a decimal number or is it an integer number? Well, this guy is a decimal number. Okay, but when we're working with decimals, it would actually be easier if we could change them into integers. What is an integer? Well, remember, an integer is a whole number or its opposite. Basically, think of them as positive and negative whole numbers. Okay, so how would we change something like 3.4 into a whole number? What could you multiply it by? Well, you could multiply it by some power of 10. What do we mean by power of 10? Well, let's look at the basic powers of 10. Here are some common ones. 10 to the first, 10 to the second, 10 to the third. So 10 to the first is 10 itself. Remember, 10 to the second is 10 times 10, so that's 100 that we are talking about. 10 to the third is 10 times 10 times 10, that's 1,000. 10 to the fourth would be 10,000, so on and so forth. So we want to multiply by one of these powers of 10 to make the decimal go away. So given what you know about 3.4, which of those three numbers would make the most sense? Well, you could use any of them, but what's the smallest number you could use? That would be the 10. When you multiply by 10, remember this decimal would move one place to the right, and 3.4 magically becomes 34. It's just important to remember that whatever we do to one side of the equation, we're going to be doing to the other side as well. And that's how you can kind of get away with this trick. Okay, so let's take a look at an example here. Why don't you go ahead and copy this on your paper right now. If you don't have pencil and paper out, you already should. So we have an equation with variables on both sides, and notice that all of the numbers involve some kind of decimal. And so we're going to multiply by some power of 10 to make all of these, not just one of them, but to make all of them turn into whole numbers. So that's the trick. Multiply by some power of 10. And maybe you're already thinking about what that's going to be. You know, are we going to multiply by 10? Are we going to multiply by 100? Is it going to be 1,000? Is it going to be something bigger than 1,000? And really what we want to do is we want to use the number that's the smallest one that will accomplish an integer status for all of our numbers. So let's take a look at the 4.53. This guy goes all the way out to the hundredths place, whereas in 7.2, this guy only goes out to the tenths. And we see a similar story on the right side of the equation. The 3.37 goes all the way out to the hundredths place, and the 49.5 goes only all the way out to the tenths. So, could we multiply these by 10? I mean, we could multiply both sides by 10. And for a number like 7.2, right, multiply that by 10, the decimal moves one place to the right. All of a sudden, we have 72. And that's good. 49.5, that decimal would move one place to the right, and we'd end up with 495. That's good. But if we multiply the 4.53 by 10, it's not enough, because we only move that decimal one place, and then you end up with 45.3. You're still going to have a decimal, so 10 is out. What about 100? 100 is going to work. Notice if you multiply all of these guys by 100, you will end up with whole numbers. For the 4.53, it's going to move two places with 100. It'll turn into 453. For the 7.2, that decimal would move two places. It'll turn into 720. 3.37 will turn into 337. And 49.5 is going to turn into a larger number. It's going to turn into 4,950. Okay, so that's kind of a preview. Let's take a look at what your actual work is going to look like. We just decided that we're going to multiply both sides of the equation by 100. So what I want you to do on your paper right now is go ahead and put the entire left-hand side inside parentheses and then give it a coefficient of 100 because you're going to multiply the whole left side by 100. Also put the entire right-hand side inside parentheses and multiply it by 100. And it can look something like this. Now, if you've already copied this down and you don't have that little space on the right side to fit that 100 in there, you can put the 100 on the right side of the 49.5 on the outside of the parentheses. That's okay too. Okay, now you are going to multiply everything on the left by 100, which means you're going to be using the distributive property here. So 100 times 4.53 will give you that 453. 100 times negative 7.2 will give you negative 720x. Okay, on the right hand side, 100 times 3.37 is going to give you the 337x, and 100 times negative 49.5, remember that decimal is moving 2 places out to the right, that's going to give you negative 4,950. Okay, so notice now we have an equation, variables on both sides, but we're dealing with all whole number coefficients, all integer coefficients, I should say. All right, so let's practice solving that. You have already worked with equations with variables on both sides, so I want you to do this one ahead of me. Go ahead and remember, we're going to collect variables first, follow all the steps that we went over. I will tell you that you're going to end up with a decimal answer. You're going to have to use your calculator toward the end to divide some ugly numbers. You're going to get a decimal on your calculator. I want you to round your answer to the nearest tenth. Okay, so do this on your own, round your answer to the nearest tenth, and then we'll reconvene to see if our answers match up. Okay, I'm hoping you hit pause there and tried this one on your own. Let's begin by collecting variables. So we're either going to take away 337x or we're going to add 720x. I like to stay in positive land, so let's add that 720x. You want to be very organized with your work because we're doing so many steps, it's just easy to make mistakes. Okay, notice that x's are going to cancel on the left hand side, and we're going to be left with 453 equals, this ends up being 1057x, and don't forget about the minus 4,950. Okay, so now we're at a basic two-step equations. We got our couple, we got our loner. We want to take out the loner, so we're going to add 4,950 to both sides. Notice when we add and subtract on both sides, we kind of line it up with a similar looking term, like a like term almost. When we multiply or divide, that ends up affecting the entire side. That's why we had to put it in parentheses up there, because we're multiplying the entire side by 100. That's a big difference between multiplication and division and addition and subtraction. All right, let's see what happens here. We got cancellation on the right hand side. This should all add up to 5,403, and that will be equal to 1,057x. Got a basic one-step equation, so now we're just going to divide both sides by 1,057. And this is the part that you probably can't do mentally, right? You're going to need to get your calculator involved for this guy. So I believe when you type this in, you end up with something like 5.11163 and some other stuff. And I asked you to round to the nearest tenth. Okay, so we'd be rounding to the nearest tenth. That is going to be 5.1. And since we rounded, you want to have that approximation symbol in there. So x is approximately equal to 5.1. Or you can have 5.1 is approximately equal to x. So I hope you got that one right. That one needs to be on your paper. Let's just cover a couple other quick things, and then I'm going to give you some practice to do on your own. All right, when you're rounding, first thing you want to be aware of is you want to put off rounding as long as possible. In other words, we're not talking about estimation here. That's when you round up front. You only do that if you hear the verb estimate. We want to round at the very end. That way you're not working with rounded numbers, and they're going to give you another number that maybe is not as precise, and you're not going to end up with an answer that matches up with mine. So pay attention to directions. If you're going to round, that should happen at the end, not in some intermediate step. Okay, round to a place that is practical. So when dealing with money, I know here it says you should round it 2 decimal places, in other words, to the hundredths place, or the penny. In some problems, it might make more sense to round to the nearest dollar. In some problems, it might make more sense to round to the nearest $100. It's all going to depend on context. But I would say, if they don't tell you where to round, yeah, take it out to the hundredths place, round to the nearest penny. And then, most importantly, if you are rounding, make sure that you use the is approximately equal to symbol. Remember, that's the double tilde, and I don't draw it, very perfectly, as you can see. I'm going to try that again. A better one in there. Yeah, I like that one a little bit better. Okay, so that's the symbol you want to use to show, hey, this answer I have is rounded. Okay, so here's your first example. I'm going to tell you that for this one, I want your answer rounded to the hundredths place, and then also practice multiplying by a power of 10 to get rid of those decimals. You're looking at some decimals here. You should begin by creating integer coefficients. Are you going to multiply by 10, 100, 1,000, 10,000? That's up for you to decide. Do that first, get all integers, and then go ahead and use the rules for equations with variables on both sides. Go ahead and get your answer on your own. You're going to need a calculator, and remember, round to the nearest hundredths place. If you haven't hit pause yet, go ahead and hit pause. Otherwise, I hope that you have finished this. Let's see how you did. So we're going to begin by multiplying by a power of 10. And for this problem, since all of our decimals, it appears, go out to the hundredths place, let's kind of counteract that by multiplying both sides by 100. So I'm going to multiply the left side by 100. I'm also going to multiply the right side by 100. Here I didn't have enough room, so I'm just going to put the 100 on the right. I'm still going to distribute it. It's all good. You can do it like that, no big deal. All right, going to have to distribute 100 times 7.45x. It's going to be 745x. Very similar number, just a little bit easier to deal with. Okay, don't forget to distribute the 100 all the way over here. That's going to become negative 881. So once again, all integers. Okay, on this side, the 100 is going to multiply the 5.29. That's going to make a 529. And then the 100 is also going to multiply the 9.47x. And that gives us positive 947x. All right, equations with variables on both sides. We want to collect variables first. My two options are either subtracting 745x or subtracting 947x. I'm going to go with this guy because he's going to keep me in positive land. And then I'm going to do that on the right-hand side as well. So minus 745x. Get some cancellation on the left. And now I should have negative 881 equals 529. And then this ends up being plus 202x, I believe. I hope. All right, got a two-step equation. Going to get rid of the loaner. So take away 529 from both sides. Notice I'm creating a get mugged twice situation over here on the left. You lose 881. You lose 529. Altogether, you have lost 1,410. And that is going to be equal to 202x. And I get a little nervous sometimes when I'm dealing with weird numbers. I'm just going to type that into my calculator just to verify it. Negative 881 minus 529. And it is negative 1,410. Just wanted to check. sometimes I use my calculator more to verify things than I do for computation. Last step, got to divide by 202. This is definitely going to be calculator action because I cannot do that in my head. But we are going to figure out what x is approximately equal to. So you want to go ahead and divide that in your calculator, and you should end up with, as a rounded answer, negative 6.98, because I asked you to round to the nearest hundredths place, is approximately equal to x. And hopefully you got that one right. Okay. If not, maybe you forgot to multiply by the 100. You'll get another one to practice on right now. So go ahead, pencil and paper. Here is your next practice problem. Rewrite with integer coefficients first, so multiply by a power of 10, and then follow the steps for equations with variables on both sides. Use your calculator, and for this one, let's have you round to the nearest thousandths place. Okay, so round your answer to the nearest thousandths place. Go ahead and hit pause now, and then we'll reconvene to go over answers. So let me begin first by asking, what's the number up here that's kind of screwing it up for the others? In other words, I would call this the limiting factor. Which guy is kind of determining which power of 10 we're going to use? Are we going to multiply by a 10, a 100, or 1,000? Well, it's all because of this guy right here. Because this number goes out all the way to the thousandths place, that means multiplying by 10 or multiplying by 100 just won't cut it. So to make that guy whole, we're going to have to multiply him by 1,000, which means everything else comes along for the ride. So you should have begun by putting the left-hand side inside parentheses, multiplying it by 1,000, and same with the right-hand side. Put it in parentheses because this happens to the whole entire side. And let's see what we get here, because I found that this is commonly where people are going to make the most mistakes. 4.5, I'm going to have to move that decimal 1, 2, 3 places to the left. That guy ends up being 4,500 in. Okay. When I distribute the 1,000 to the negative 0.375, 1, 2, 3, that guy just becomes minus 375. Over on the right-hand side, when we multiply 0.75 times 1,000, remember that's going to move 3 places, I end up with 750 in. And then this one's a little bit tricky. 2.0 times 1,000, well, that's really just saying 2 times 1,000. I'd move this 1, 2, 3 places. That's 2,000. So check and make sure this is what you had. You should have 4,500 in minus 375 equals 750 in plus 2,000. Okay, I'm going to collect variables. So our best move, in my opinion, is to take away the 750 in from both sides. And when we do that, we get 3,750 in minus 375 equals 2,000. Okay, got a couple and a loner over here on the left. We want to get rid of the loner. So let's add 375. And we end up with 3,750 in equaling 2,375. That's your basic one-step equation. Now you want to take both sides and divide by the 3,750 to get rid of that. And that's the number that you're going to need to type into your calculator. Now I asked you to round this to the nearest thousandths place. And I'm going to do that myself really quickly. So you should have 2,375 divided by 3,750. And looks like you get 0.63 repeating with the 3 repeating. So when we round that to the nearest thousandths place, 0.63 0.633 would do it. And you don't need that 0 there. It's optional, so even just 0.6333 would be correct. And hopefully you got that one right. So that's the trick. If you have decimal equations, you're going to multiply by some power of 10 just to turn everything into whole numbers, and then you're less likely to make mistakes. All right, good job, and good luck with the assignment.